Thank you very much. Let's start. Right. So my name is Anton Babenko, and for many years I've been having a lot of fun working with Terraform and AWS and develop several open source projects. Some of these projects are pretty useful for many people. Some people use them pretty much on daily business, and yeah, they have been receiving a lot of benefits because that's how open source work. So before I go deeper, I really want to figure out like audience here. So let me ask, like, who knows what is Terraform, or who use Terraform, Serverless? Excellent. Oh my God, that's really a perfect fit. So thank you very much for finding time and for not going and listening functional programming, but listening to me. Because I'm not a big fan of functional programming, not big expert, I would say. So great. Terraform is alive, Terraform is used, and you can see it, right? I mean, you have been using it for some time. So let's don't think about deep fakes and whether Terraform is deep fake and now we should switch to OpenTofu. No. Just keep using whatever you've been using. So this talk I will talk about Serverless TF project, which is website, and I will explain how it works, and I will make a demo. If you have any questions during the talk, I think it's okay if you ask questions right during the talk if something is not clear, because we are like small cozy room here with many empty chairs. If you have interest in learning Terraform, and if you want to see how I write Terraform modules or how I talk to different developers and do different tools review, feel free to subscribe to my YouTube channel. And if you also like to stay up to date with different news, I publish Terraform weekly newsletter on weekly.tf every Wednesday. So this talk is about Serverless TF and Terraform AWS modules. So Terraform AWS modules is a collection of more than 50 open source modules supported by the community with more than 200 million downloads so far, and it's approximately 500,000 downloads every day. So it's quite a lot of scale. It's many different modules for many different services, and yeah. In this talk, I will focus specifically on serverless. Again, I think we'll understand what is serverless architecture, but just like briefly, I want to explain that in this diagram, we have user who is reaching out API gateway, and then API gateway can forward requests to one of AWS Lambda, to write Lambda or to scan Lambda. And also there is DynamoDB service on backend where some data is stored, and CloudWatch, because why not, logs will be stored there. This is very simple architecture, but nevertheless, it should show the point how certain things are working. With serverless architecture, it's important to understand that we are not spending a lot of time managing individual servers because they are managed for us. We should focus significantly more time not on patching and dealing with internals of each of these servers, but writing application code, package it, and hopefully submit it to AWS Lambda service, and it will create instance of Lambda function, which we can call. In this case, application service is the most important thing. Application code in AWS Lambda, for example, can be written in any programming language. So if we are talking about serverless, we may think that, okay, we have our application code, which is inside of Lambda, fine, but we already use Terraform for the rest of our infrastructure. So the idea of Serverless TF project is to unify this. Let me explain a few available options. And we can use something what is, as I call, default for serverless. AWS has serverless application model, or there is serverless framework, which was one of the first solutions out there. and it took the whole kind of attention that people think that serverless framework is the way to do serverless applications. It's one of the ways, and currently in 2024, it's not one of the best ways anymore. By many different reasons, there are better projects with more suitable, more supported, and quicker and easier to use. So available options for managing infrastructure is obviously infrastructure as code tools like Terraform, CloudFormation, or CDK, or plenty other tools. Again, it's important to understand that we have tools to manage infrastructure for quite a long time. And also we need to do something with deployments, like how can we package our Lambda function and put it somehow into AWS service like Lambda, for example. We can use shell script, or we can use our own make files, or we can use specific services like AWS Code Deploy, or we can call just AWS CLI directly and call different methods there. You also need to understand that all of these solutions were not developed for serverless in mind, and there is no one way how you can integrate these solutions and everything will be fine. So get ready for so-called yak shaving, where you start one thing and then you go deeper, 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 and then the rest of the day you figure out that you didn't do anything and just debugging, right? I mean, we all do yak shaving for the whole day, and then we realize that, yeah, it was missing semicolon somewhere. So typical problems with this solution is we have too many overlapping solutions, and it depends who you are talking to. You will hear people saying that, oh, my solution is better because of X, Y, Z, or another. If you go to another team or another organization, and you will hear that, oh, we use, for example, CloudFormation, and we are not afraid of writing 1,000 lines in PowerShell. Okay, that's sad to hear, but that's your problem. So accidental complexity is going to be significant if people are not questioning what they do. If they simply say like, okay, I have, let's say, one day to get it done, so obviously they will go to ChatGPT. ChatGPT will tell them, you need to use this 50 lines of shell script, and people will use it without questioning how to optimize it, how to refactor it, how to integrate it with the rest, and so on. And from time to time, people will actually understand that there is some overlap between traditional resources or traditional infrastructure resources and serverless. So if you ask people for example, AWS VPC or AWS S3 bucket, most of them will say like, oh, this is not serverless. This is like resource which we manage in our traditional infrastructure as code tool, and we maintain state of it, and we do a lot of work to keep it up to date. But if you ask them where AWS Lambda belongs, most likely all people will say that it's definitely serverless resource, and we probably need to use something what is built for serverless. For example, serverless framework. What I think is that there should be some alternatives. As I said earlier, the solution to many overlapping solutions should be clear distinguish between application code, which is written in any programming language you like, and you focus on that stuff pretty deeply. And your infrastructure code is already in Terraform. So think about that you don't need to sacrifice, and you don't need to say like, okay, there is still place to bring serverless native solution like serverless framework. Because at the end of the day, the point of Terraform is that it's smart enough to understand how the relation between all resources should be handled. So it can understand and it can build very complicated graph, and then it can enforce this resource creation. And that's exactly why we appreciate Terraform, because we can see what's going to happen, and we can reliably run Terraform plan. We can examine it, and then we can run Terraform apply, and we can follow the process alone. While if you use most of other solutions which are currently available, you will have sometimes very hard time to figure out what has actually happened. I'm talking about CloudFormation specifically. You will see that something is failing, and then you need to do a lot of, as I mentioned earlier, rabbit holing to figure out whether there was problem in your code or AWS problem or what's happening. So you will spend quite a lot of time dealing with that. And accidental complexity is, again, very important to understand that when you're writing something in your programming language and you solve some business need or business, you write some business application, business logic, that's where you should spend most of your time and energy, not fixing plugins of your tool, not patching something what shouldn't be even kind of on your plate at all in the first place. I'm specifically mentioning serverless framework, where most times, and when I talk to many people, they say that they have been in the same position as myself, where we use serverless framework, and then if there is some issue, we suddenly have to become JavaScript experts, and we need to go very deeply, very soon, just to understand whether there is bug in my usage of this plugin or its internal usage, and so on. So that's why managed solutions like CloudFormation, where you don't see what is inside, you just use it. You don't have a lot of ways to extend it. Or Terraform is much easier to avoid accidental complexity. And overlapping infrastructure management is still a pretty big problem because some solutions exist or easier to implement, or people were told that they're easier to implement if they would be using, let's say, programming language. Then you can use AWS CDK to generate, for example, IAM policy. It looks cool, and you think that that's the right way to do. But then the rest of your infrastructure is in Terraform. Why not use one tool which can do this extremely efficiently? Does it make sense so far? Good, 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 good. That's what I want to hear, because now we are going to Serverless TF. Okay, so Serverless TF is open source project which is available on serverless.tf. I started it 4 years ago because I was looking for easy way to manage serverless resources and so actually to create infrastructures on AWS. I didn't want to manage like low-level component, because just for those who don't know, if you want to create Lambda function, it's not one resource. It's at least 10 resources. It's a lot of policies, a lot of execution roles, a lot of attachments, a lot of aliases, and more. Plus, you need to build your package with the code. So that's how Serverless TF started. Now Serverless TF is officially recommended by AWS. If you go to official AWS website and you search for documentation how to get started, Serverless TF is mentioned as the only way if you're using Terraform. So that was pretty cool achievement. After almost 4 years, AWS figured out that this is not just my hobby project which will die tomorrow, because that was the initial feedback. I was a bit disappointed because, come on, it's not a hobby project. I mean, I made it for myself and for people who I work with. So then they say, like, okay, yeah, we see that 500,000 people download it, so probably it's not dying. And the amount of components has been growing constantly. Amount of people who contribute, who use it, who provide different support is pretty big and pretty stable. So what is actually Serverless TF? So Serverless TF is a collection of very decoupled modules for all possible serverless tasks when it comes to provisioning, configuring all AWS services which you typically use within serverless infrastructure. Though there are a lot of modules in Terraform AWS modules organizations which can be used to configure any other services. In total, we have more than 50 modules for all possible services. And the Terraform AWS Lambda module has started specifically as a solution to the problem where making Lambda function was not trivial. And I wanted to make it as simple as possible so people don't need to go and study internals and details of how Terraform works, how Lambda works, how to configure a bunch of things. So I will make a demo of it in a bit. It is also fully open source, and it was designed with the idea that you have your application code and your infrastructure code as close as possible. So for people who are writing infrastructure code, they can manage infrastructure and deploy Lambda functions in the same go. So they simply run Terraform, and Terraform figure out what should happen, how to build package, how to put it in S3, how to upload it from S3 to Lambda function, and so on. So let me demonstrate how this actually works. Yeah, I have it here. Cool. So this is folder 2023, and inside of this folder you can see files with TF extension. TF is not territory of France, though it is territory of France if you want to register a domain. It's $14 a year, and you will receive a lot of funny traffic because it's an official domain. It's not like a very new domain where nobody knows. It's a very old domain, and you can get it for $14. Okay, enough about add. So let's talk about how to create Lambda function. So this is an example of how Lambda function can be created. So this is typical Terraform configuration code where we have module block, and here we specify that we want to use this Terraform AWS module for Lambda, which version, and then we specify what kind of properties do we want. Here, in this case, I specify that I want my function to be called somehow, and I want to have this runtime, Python 3.8, and I want to use this handler. The rest of these properties is to configure the rest of relations, like how to specify execution role for this Lambda function, or who is allowed to call this Lambda function, and so on. All of this module has documentation. I can look into Terraform modules, Lambda, and this is source code of the module, which you can look into. Of course, it's publicly available if you go to the registry. Here you will see that you can see documentation here, or you can see examples, and you can see that there are a lot of different examples for all possible features, how this can be used. So if I look further here, this was the way how to configure, let's say we take source code from this folder, and then this Lambda module will figure out what is necessary. It will understand that for Python, we need to install pip install using requirements.txt file, and that's it. It will just figure out this by itself. Yeah? Yeah, so handler is the file name and the method which is being invoked by this Lambda function. So if I go to this location src Python function, if I go to src Python function, and then there is index py, which is this index, and then inside of it there is a function called Lambda handler. This is it. So this method will be called as entrance point for this Lambda function. And this is going to happen inside of it. So in this case, it will just return hello from serverless TF Lambda function. So if I want to run this code, all I need to do is just run Terraform init, and Terraform init will download modules which I was referring to. In this case, it was Lambda function module, as well as ACM to create Amazon Certificate Manager certificate for specific domain, and it will create API gateway. And one more thing I want to mention in API gateway is that when I want to create an API gateway, it's extremely important to be able to refer or to connect all other modules output. For example, if there will be get method to slash, then it should call this lambda get function. If there will be post method to the same slash, then it will call lambda post. So I'm creating two different lambda function and connecting them through the same API gateway. API gateway is also very configurable with all possible options available in Terraform AWS provider. So Terraform has a provider with many different resources. And that's how you can call it. So now if I run Terraform init, I downloaded everything, and I want to just run Terraform apply. And Terraform apply will plan what's necessary to create. And in this case, it says it wants to add 40 resources. 40 resources necessary to get this thing done. As I said, it's creating not just 4 or 5 resources, but it's actually creating all execution roles, policies, and so on. So I confirm this, and after some time, it will create all resources in correct sequence and use them. So that's pretty much a demo. As I said, everything is open source, and you can find something is not working, which is live. Yeah, I don't know why it's not working. Ask developer. Yeah. No, it was working recently, but then I updated modules, and it doesn't work anymore. Yeah. So once it finished, then it will output where this Lambda function is present. So let me go back here and just summarize it a little bit in maybe a little bit different view. So the core here is that I have reference to my application code, which I can build, which I can have somewhere near the infrastructure, and I can tell infrastructure module to use source code from specific location. Or I can pre-build this package and upload it on S3, and then Lambda function will not build this thing, but it will just use existing solution and deploy it from S3. Yeah, and that's what I showed. And also, this example creates DynamoDB table. As you can see, the configuration for DynamoDB table in this case is very lean. Again, the point of the module is you should be treating them as libraries in any programming language, right? In libraries, you don't go and study internals right away. You just call it first to get your job done. And then if you need to extend it, you can go and study how certain things were implemented, and you can extend them because this is fully open source. And yeah, there are many different ways to build Lambda function, and it has support for many programming languages like shortcuts, pip, poetry, and PM is built in, but you can also extend it to support Go and Java or Rust, whatever you want. Also, there is a way to build it in Docker for different platforms, for different architectures, and so on. That's pretty much it. There is a lot more information if you go to Serverless TF or if you go to specific module and go to example folder, all of this is shown there. That's it. Thank you.